Hello everyone and welcome to the lab. In this part of the lab, we are going to talk about the fundamentals of the R language. I'm going to show you some basic functions that you can use, and by the end of the lab, you should have all the tools you need to complete the first lab assignment. So you'll need two things. First, you need to make sure that you've downloaded R and RStudio. If you haven't, go back to the previous lab video and take a look at how to download all the software that you need for the rest of the semester. And then for this lab and the remainder of the labs in the semester, I think the best way to approach it is that if you have access to two monitors, you might want to open up this video on one monitor, and then on a second monitor, have an instance of RStudio open for yourself so that you can type along with me. And the way this lab is going to work is that I'm going to open up a brand new R script. I'm going to go ahead and start coding and showing you guys how it works. And it would probably work best if you're coding alongside me. I'm probably going to make mistakes along the way. You guys might make mistakes along the way as well. But I think that's the best way to learn. Now at the end of the lab today, I'm going to upload all the code that I write here to Canvas, and I'm going to make sure that it's fully commented and annotated. And so if you want, you can go ahead and download that and work through that yourself to just make sure you understand all of the functions that I'm writing out here. So that's a second way that you can approach these labs as well. If you don't want to code alongside me, make sure you open up that R script and go through the code line by line to make sure you know what's happening at each stage. Okay, so assuming that you have R and RStudio downloaded, go ahead and open up RStudio. So you can do that by clicking on the icon down here in your toolbar. It might be on your desktop as a shortcut. You might have to go to your Start menu and go up to RStudio. But go ahead and open it up. And it's going to look something like this. You're going to have a number of different windows here. If you don't have this window in the top left that says Untitled 1, so it would look like this. Go to File, New File, and RScript, and that'll open up that window. So let's just take a minute and talk about what each of these windows are. So first in the top left, you have this window that says Untitled 1. This is going to be your text editor. This is where you write all of your script. You prepare everything up here. You can go ahead and edit it and change it and save it and come back to it later. And this is where your sort of preparation area. Once you prepare your code, you send it down here to the console. So I'm just going to change the size of this window here. And the console is really the sort of engine in RStudio. So this is where you send your commands. Once you enter them into the console, your computer will go ahead and run all the computations that you're asking it to run. So if you were to just open up R itself, all you would get is the console. RStudio has all these added benefits of having your text editor up here and then these other windows that are also really helpful. So your third window up here is your environment. This tells you all of the objects that you create in R, all of the variables that you create. Whenever you read data into R, it will appear up here in your environment. So that's really helpful. There's also a history tab, so you can go back and look at all of the commands that you've run previously in this session of RStudio. Right now these are both blank because we just started it. And then down here in the bottom right, we have our plotting window. So when we start to generate scatter plots or density plots, histograms, whatever, they'll appear down here. And then we also have a help tab. And now this is really helpful, especially when we start using more and more advanced functions later in the course. So whenever you have a question about the function that you need to use, you can come down here to your help window and search for it. Okay, now one of the first things I'm going to do just before I get started here, I'm going to change the text size in my editor. So I'm going to go to Tools, Global Options, and we'll go to Appearance. So you can do this for yourself if you want to change the way RStudio looks for you. I'm going to increase my text size to, let's go 14. Seems reasonable. I think you should be able to see this. If you want, you can choose one of these really cool editor themes. So like if you want to feel like you're in the Matrix, you could go to Twilight, click Apply, and now all your text is white and the background's black. It looks really cool. It might be a little bit distracting for a tutorial like this, so I'm just going to go back and switch to my default text mate. Apply. Okay, great. And we are ready to get started. Just shrink down these windows a little bit. I like to keep my text editor a little bit bigger than the other windows because that's where I'm doing most of my typing. Okay, and let's go ahead and get going. Okay, so one of the first things you want to be aware of is that R can function just as a normal calculator, and the operations are just like in Excel. So if we want to do like 5 plus 3, now I've typed this up in the editor, and when I want to send it down to the console, I can do that one of three ways. I can just have my cursor active on that line of script, doesn't really matter where, and click Run. Sends it down here to the console, runs it, returns a value of 8. Now it hasn't stored that value anywhere, it just returned it and then immediately forgot it. I could also highlight that script and copy it. So I could, if I'm on a PC, I hold down Control and press C, or I right click and go copy, bring it down here, click inside the console, and now I'm going to press Control V if I'm on a PC, or I right click, go paste, and then I press enter and it does the same thing. Or I can just highlight chunks of script I want to send down and click run as well. So like if I wanted to do 5 plus 3 plus 8, but I just wanted to send down the 3 plus 8, I could click run. It sends down 3 plus 8 is 11. If I want to do the entire line, just click on that line, click run, and it does the entire operation together. Okay, so that's addition. I can do subtraction in the same way. Send that down. Multiplication uses the asterisk, just like in Excel. 5 divided by 3. Okay, 5 times 3 is 15. 5 divided by 3, 1.66. Great. If I want to do a power function, 2 to the power of 8, just like in Excel, I could do it like that. Or I can do double asterisk. Those should give me the same result. Let's try that. Yep, both give me 256. R also has a ton of built-in functions. So if I want to calculate, let's say I'm doing some trigonometry, and I want to calculate the sine of 1.8, I type sine, and then I surround the number with these round parentheses, sine of 1.8. R also knows what pi is, so if I wanted to do just pi, I could run that, and it tells me it's 3.14. Okay, and then just like in Excel, if I need to do order of operations, again, I use parentheses. So I could do 3 plus 5 times, and then 6 minus 1, just like this. And so it's going to do the 6 minus 1 first, then it's going to multiply that quantity by 5, and then it's going to add 3 to that quantity. Just like that. Okay? Now, one of the first errors that you're likely to encounter when you start coding is that you're going to miss a closing or an opening parenthesis. So if you miss an opening parenthesis, like this, now this line of code only has a closing parenthesis. I try to run this code, I get an error, and it says there's an unexpected closing parenthesis in my code. And so I would need to come back up to the text editor, take a look, where did I mess up? Okay, in this case, I should have had it there. I run it, and it would work just fine. Sometimes you might miss a closing parenthesis, just like this. And if I try to run that, I get something slightly different. Click Run. And now you can see down here this little plus sign happened. It tells me that it's waiting for another closing parenthesis. It's waiting for something to close off that. So if I knew what happened, I could just close it myself and press Enter. Or maybe I have a whole bunch of lines of code. Somewhere in there I missed a parenthesis and I don't know where that is. I would just come down here to my console, press Escape, and then come back up to my editor and start looking for where I missed that parenthesis. I go, okay, there it is right there. Close that, and then I could go ahead and run my code. I can run all of these functions, all of these operations at once if I want, so I would just select that whole thing, click Run. It runs them all at once, just like that. Okay, and just a couple other functions you might want to be aware of. So you can calculate the square root just with this function, sqrt. This is all lowercase. R is case sensitive, and I'll show you what happens if you have the wrong case in just a minute. But let's try the square root of 9. That should give me 3, right? Perfect. Okay. If I mess up the case sensitivity here, I do like capital letters. I try to run this. I get this error. And R tells me that it couldn't find the function capital SQRT. So R is case sensitive. For the most part, you're going to be writing all your code in lowercase. Very rarely will you want to use uppercase. It just becomes confusing that way. Even when you start creating objects, you want to usually keep them in lowercase. Okay, before we get any further, I want to talk about commenting your code. And so I'm going to try to do this really thoroughly, maybe not even during this tutorial, but after I finish the tutorial, before I upload this to Canvas, I'm going to make sure the code is really thoroughly commented. And that comments are just used to keep track for yourself and for other people reading your code exactly what you're doing. So the way you create a comment is you put this little pound sign or hashtag if you're in the Twitter era, and in RStudio it colors it a different color to let you know that, okay, everything after that comment is on that line of code is not going to be read by R when you send it down to the console. So up here I'm going to write basic operations. Okay, I could come here. So if I wanted to run that first, I send it down to the R console, reads it, nothing happens. And that's because it's preceded by this pound sign. Now R reads its commands from left to right, and then after that it reads them from top to bottom. So here I could put a comment on this line, and everything after this pound sign on this line of code will not be read. So I could go addition here. Okay, here I would write subtraction. So if I run this line of code, okay, it does 5 plus 3 plus 8 and then ignores this addition, but it keeps it in my script so that I can keep track. If I come back to this a month later, when I upload this to Canvas, you guys can read exactly what I'm doing on each line. So this is a really, really good habit to get into, and I'm going to expect you to make sure that your code is thoroughly commented. There really isn't a hard and fast rule about how much is too much or how much isn't enough, but just try to use common sense. So you're going to comment your code enough that I should be able to tell on every line what exactly you're doing. Now, in your normal code, you probably wouldn't need to comment something like this because it's obvious that I'm just doing a really simple operation here, and adding a whole bunch of code there probably isn't necessary, in normal day-to-day life. But when you start using more complicated functions, or you're wrapping functions within other functions and things start to get really unwieldy, it's a really good idea to comment your code and just make sure that everyone can tell exactly what you're doing. Okay, I'm going to come back down here. I'm just going to write this, and I'm going to write a comment here, error case sensitivity. Okay, just a few more useful functions in R, and as you get better at programming, you're going to build up this sort of library just in your own memory of which functions you can use in R. So here is a really useful one. It's going to create a sequence of numbers. So I can create a sequence, say from, I don't know, like 5 to 15, just by using this colon. And when I run this, you can see down here it created a sequence of numbers. Now I can also create a sequence of numbers using this sequence function. And so I can go sequence, and I go from, 3 to go 15 by 1. Okay, when I run this, it goes from 3 to 15 and it increments by 1. I could also, if I wanted now, this is why this sequence function is really useful, because I could increment by whatever I want. So I could go 0.1, and now it's going to create a massive sequence of numbers going from 3 all the way up to 15. Okay, now how did I know that the inputs for this sequence function were from, to, and by? I can check the help function, or I can check the help page for this function by using this question mark. And so I go question mark sequence, and I press enter. Okay, actually let's send that down to the console. And down here now in my help window, I have a page that tells me about that sequence function. So it tells me that, okay, seq is just, it's in the base library of R. Okay, so it just comes, I don't have to upload it, I don't have to load any fancy packages to use it. This is for sequence generation. It gives me a little description, so it's for generating regular sequences. And then down here it tells me a little bit about how to use it. So I need a from, a to, and then a by. Or I can use this length dot out. And so I like to come down to these this arguments section, and this tells me exactly what I need to put in. So the from and to are the starting and end values of the sequence, and then by is the number that I increment that sequence by. Or I can use this length dot out, and so let's check that out. Come back to my script. Let's go sequence from equals 3 to equals 15 length dot out. Now I'm going to leave the by out of it. I'm going to say I want 18 numbers, and so this is going to create a sequence from 3 to 15, and it's going to give me 18 values in there that are equally spaced between 3 and 15. And so it's exactly what it's done. And so now I didn't need to know what that increment was. It automatically calculated that for me. Now, all the time in R, you don't have to actually specify this from and to and length dot out. R, you can take some shortcuts sometimes. So if I want to do sequence 3, 15, and 2, now let's see what that does. Okay, so that just R knew that I wanted to go from 3 to 15, and then it's incrementing by 2 each time. And so now if I did want to change this to sequence 3, 15, and I actually wanted the length out to be something specific, I do need to type length out equals whatever I want, 20. Okay, so R does have some sort of default settings. It's going to assume that the first argument that I put into this function is 3. The second argument is, or the first argument I put in is from. The second argument I put in is what it goes to. And then it just automatically assumes the third argument I put in is the increment by. If I want to change that, I need to actually specify that myself. Okay, so let's see what this looks like. Perfect. 3 to 15, and it's giving me 20 numbers that are equally spaced in there. Okay, let's just comment this section really quickly. So this is sequence from 5 to 15, incrementing by 1. Sequence function. Using the help window. Okay, and then here we had using the length dot out argument. Okay, and then here, these two next ones, we're just going to go comparing, or let's just call this using the default arguments. R knows what I'm looking for. That sounds spooky. Okay, and here is modifying the default arguments, specifying length dot out. Great. Okay, now let's just assume maybe I wanted to create a sequence in R and I had no idea how to do that. And I didn't know that there was a sequence function, so you're going to come across this for sure when you start programming. You're going to want to do something with your program, and you're not going to know how to do it. You're not going to know if a function exists to do it. And so the best way to check that is to actually go to Google and search up what exactly you're trying to do. And so I'm going to show you how to do that right now. Let's think of an example here. So let's assume maybe I wanted to create maybe I wanted to repeat a certain value a certain number of times. So let's say I want to repeat the letter A 200 times. And I don't know if there's a function in R that can do that. I have no idea how to do that. So I'm going to go to Google, just like this, and I'm going to type repeat value in R. Okay, I click on that. Sequence, so I get a whole bunch of different pages. Let's go ahead and take a look at, I don't know, yeah, sure, this top one. Okay, so this is just really the help page from R. Tells me that, okay, I need to use this rep function. and replicates the values in x. Okay, so I would put like the letter A in x, and here we go, rep x a certain number of times. Now a lot of this sort of looks like hieroglyphics. This might be really hard to parse out, like what exactly are the arguments I need to put in, what's times, the length out, all this different stuff. I can try to read some of the details down here. Okay, this looks a little more helpful. So rep x is the thing I want to repeat, the times. I can change the number of times I want to repeat that. Okay. The really helpful part is when I come down here to the examples. And so down here, this gives me some examples of how this is being used. So I'm going to, for example, down here. Okay, let's actually just copy that. Control C. I'm going to come back to my RStudio, and I'm going to use this function. Now let's see. I said I wanted to repeat the letter A, and so to create a character here, I just want to surround the letter A with these quotation marks, and I want to do it. I think I said 200 times. It's a lot. It's probably going to take up my whole screen, but let's try this. So rep A 200 times. There we go. I repeated A 200 times. So that's how you sort of go about looking up functions to do things that you don't know if it's possible. You don't know if there's a function out there to do it, but go ahead, use Google. I definitely encourage you to use Google as much as you can. Ask each other, ask friends, and that's the way you're going to start doing it when you start programming on your own outside of this course. Just comment this quickly. Repeat the letter A 200 times. Now up until this point, we've been running these functions, but we haven't actually been saving anything into R's memory. And so it just runs the function once, spits out an answer, and then from R's perspective, it just forgets it. Now, a lot of the time, we actually want R to start saving objects into its memory so that we can use them later on. We can use them later in our code. Sometimes we might actually want to save them to our computer in like CSV files or Excel tables or whatever. And so to do this, we need to start creating objects. So I'm going to create a header here, objects. We can tell so far that R hasn't saved anything in the environment because up here, our environment is empty. Once we start creating objects, we're going to populate this environment. That's going to tell us everything that R has saved in its memory. So the first object I'm going to create, I'm going to call it X. And I can think of this just like a variable. So X, I assign it a value using this equals sign. And let's make X have a value of 5. Now I run this. And we see two things. Number one, it didn't immediately just spit out a value of 5 down here. But it did save that value of X up here in my environment. And so if I wanted to return that value of X, I could do that in two different ways. I could go just X right here, run that, and it tells me that the value of X is 5. Or I could use this print statement. Print X. Now, a lot of the time, these two things are sort of the same, and so to save some keystrokes, you won't want to do this. But when you start running really long strings of code all together, it may not actually return the value when you just type in X like this. And so sometimes in more advanced programs, you want to use this print function. Right now, it's a little bit redundant, but let's go ahead and run that. And it just does the exact same thing as just calling X itself. Let's create a new variable called y, and let's assign it a value of, well, you can actually use functions here. So let's just say I want to assign y a value, whatever the square root of 5 is. Okay, I would do it just like that. I want to see what that value is equal to. I could just look up here in my environment, but it's probably a better idea in general just to return that value of y, 2.23. And I should point out, you can actually assign objects. Instead of using this equals sign, R has this weird sort of idiosyncrasy where you can use this this sort of arrow symbol here. Now this is 2 keystrokes, and I don't know, I just kind of think it's sort of a waste of time. It's a little confusing. You'll see this in a lot of other people's code. I prefer to just use the equals sign in general. just seems a little bit cleaner. But I will just right here, you can also assign objects using the symbol. I have those two objects saved, so then I can create a third object based on those two objects. So I could do some function of x and y. Let's call z is 2 times x plus, I don't know, 1/5 of y. And if I want to do that, okay, run that. It's going to calculate z, and then I want to see what z is equal to, and I get that value returned. Now, here's an important point that you'll probably run into when you start writing your own code, and this can be the source of a lot of errors if you're not careful. So R is what's called a fall-through language, and what that means is that, again, as I said earlier, it reads from left to right and top to bottom. And so let's say that I reassign a value of x, and let's call x now 1,000. Okay, I reassign that value of x. So I run, it overwrites the old value of x, inputs a new value, x is now equal to 1,000. Now that should change my value of z, right? Because z is a function of x and y. And if I ask for the value of z, and I run that, look at that, I still get my old value of z returned, even after I've changed the value of x. And that's because what I need to do to get that new value of z is rerun I need to rerun that function again. Okay, so y hasn't changed, but I do need to rerun the calculation for z. And so I'm going to rerun that. And now in this new calculation, it will adopt that new value of x. Y hasn't changed yet, but it will take on, if y had changed, it would recalculate using that new value of y, and then it will return that new quantity. So let's try this. I'm going to rerun that calculation with x now being equal to 1,000, and let's see, has z changed? Yes, it has. Great. Okay, so what this means is that good practice is that you are always going, if you start changing values of certain variables, you're going to want to make sure that any operations that use that variable are also rerun after you make that change as well. I mentioned earlier that R is case sensitive, and so if I want to do something like this, I'm going to say capital X now is equal to 15. And I run that. Now I could ask for what is capital X, and lowercase x is a different value, and so then I would need to be careful. If z was a function of x, I need to make sure I'm using the right x, the lowercase x, and not the uppercase x. That would make a difference. And this is why, in general, it's also good practice to just keep all of your script as much as you can lowercase. Don't start assigning one variable in uppercase, another variable lowercase. It just becomes really confusing, especially if you're tired or if you're giving your code over to someone else. Just try to keep everything lowercase for the most part. I can check what variables are in my environment either by looking up here in my environment, or I can also use this ls function. That just lists everything that's currently in my environment. I just leave these parentheses open, just like that, or empty. And it tells me that I have x, little x, capital X, a y, and a z. And if I wanted to say remove one of those, like erase them from R's memory, I could use this rm function. And I would, let's say, I don't know, I realize that I don't want to have that capital X in there. It's too confusing. I remove capital X using this. I can see that it disappeared from my environment, or I could do ls again. I don't see any capital X in there. If I call on capital X now, it tells me that that object is not found. It's because I deleted it. I can also remove everything from my memory. Say I just want to wipe the slate clean, start over. I do this a lot, and it's really good practice if you're starting a new script. Put this command at the top of your script to just erase anything old that was just sort of lingering in R's memory. I'm going to go remove rm list equals ls. Okay. And so this is going to tell R to clear everything from R's working memory. This won't delete things off of your computer. This just deletes anything that's in R's working memory, all the variables you've created in this session, but like if you've saved stuff to your hard drive on your computer, this won't touch any of that, so don't worry about that. So I'm going to run this, and you're going to see that all the values up here in my environment go away. Gone. And so now if I was to call X, Y, Z, capital X, those are all gone. Okay, if I wanted to get them back, I could just rerun my code. Let's just, I don't know, run it right down to here. I run that whole chunk, it runs everything, and I see that those values are back again. Okay, I can erase them again just using that. So far, the objects we've been creating just stored one value in them. So Z had one value, X had one value, Y had one value. But often the type of data that we're interested in using, we might have, say, like a whole bunch of values that we want to store all together. And so we're going to create vectors to store all of that information in. So let's go down here, and we'll call this vectors in this heading. Actually, let's make this just look a little prettier. All of these headings really quickly. That looks a little better. Okay, vectors. So again, a vector is going to be just a sequence of values that are all stored together. They don't have to be an ordered sequence, but they do have to be values of the same type. So numbers would all get stored together. Character strings, like words, letters, those would all get stored together, but you can't mix numbers and letters together within a single vector. So let's go ahead and create a vector. Let's just think of an example here. Maybe we have a few data points on, say, the weight of maybe, I don't know, a few different female elk that are within a herd. Okay, we'll call this vector weights. And now let's just say our values here are going to be, I don't know, maybe they're in kilograms. How much do female elk weigh? Like maybe 200 kilograms or something. So let's say we have 5 different female elk. Now I'm going to create my vector using this C function that just says combine different values together into a vector. Let's say the first elk is exactly 200 kilograms. The next one is going to be, maybe she's really light, 150 kilograms. We have a big one, 225, 250, and I don't know, 210.5. Okay, these are 5 different elk. I've created this vector using C, and I separate each of those values using a comma. Run that, and now I call on that vector, and it returns those values back to me. Vectors are super useful because you can do a whole bunch of functions to them that you can't do to just a single variable. So I can ask for what is the mean of this vector using this mean function. So what is the mean of weights? It tells me the arithmetic mean is 207.1. What's the standard deviation? That's something often we're interested in, especially when we start getting into descriptive statistics, and that's going to be in a couple weeks. So maybe next week. Okay, there's the standard deviation. Okay, I can also use this length function if I want to know how many observations have I included in this weights vector. So let's go, what's the length? Weights. That's actually kind of confusing. What's the length of weights? Weights is my vector, and this length function tells me how many elements are in that vector. So I have 5 elements in that vector, 5 different observations. Maybe I want to sort these weights from smallest to largest, and so I could use this sort function, and then I write weights in there, run that, and now it sorts it from 150 all the way up to my largest elk, which is 250 kilograms. Okay, so this just sort of is starting to show you the power of using vectors. Vectors are also really convenient because let's say I need to convert these weights. Maybe these are weights in kilograms. elk weights in kilograms. And maybe I want to say convert elk weights in kilograms to elk weights in pounds. Okay, so what's the conversion from kilograms to pounds? I think the conversion is something like 2.2 pounds per kilogram. And so maybe I want to create a new vector called weights, and I'll call that pounds. I could do this. I could go weights in pounds are equal to the weights in kilograms times 2.2. Run that, and now when I call on those weights again, those are the weights in kilograms, sorry. I ask for the weights in pounds. This is why you should be like really careful with how you're naming variables. It's starting to get a little confusing, but weights in pounds now. Okay, so now we have the weights listed in pounds, and each of those elements in that vector has been multiplied by 2.2. You can see that right here. 200 times 2.2 is 440. 150 times 2.2 is 330, and so on. So just to reiterate, when I perform just a simple mathematical function on a vector like this, it's going to take every element from that vector and do that same mathematical calculation to it. So every element in that vector gets multiplied by the same value. Now let's say I want to pull out a specific observation from this vector. Maybe I want the third elk that I measured. I want to figure out what was her weight in kilograms. Now, if I only have 5 observations, pretty easy. I could just go back and look at the data. But when I have like thousands, tens of thousands, hundreds of thousands of observations, and I want to pull out specific ones out of that massive data set, this is when this becomes really useful. So if I want to pull out the third observation from this vector, I reference that vector, and then I ask for the third observation using these square brackets. So just like this. And this should pull out the third observation, 1, 2, 3. It should return a value of 225 when I ask for this. Sure enough, it does. Maybe I want the third one in pounds. So now I'm referencing this vector I created called weights in pounds, third one, and it gives me 495. I mentioned that vectors need to be of a certain type, and so far these have all been numeric vectors. I can check that, one, by coming up here to my environment, and I see that it tells me weights and weights in pounds are both numeric. If I wanted to actually run a command to check that manually, I could run this str command, this function, and this tells me the structure of that vector. So let's say I want to find the structure of weights. Run that. It tells me it's a numeric vector. It has 5 elements, 1 to 5, and then it gives me a little bit of information on what those would be. Now, if this was like 500 elements long, it wouldn't tell me the values of all 500 elements, but it just gives me a little bit of information there. I can also use this class function, and this will tell me that weights is a numeric vector. It's of the numeric class. But what happens, for example, if I had a character class vector? So let's say elk. Let's say that I had, maybe I had tagged these different elk, and they had different numbers and letters assigned to them. So elk names. Okay, I'm going to create a new vector here for their names. And let's call these, well, I probably wouldn't tag them this way in the wild, but we'll call them elk1 and elk2, elk3, 4, and 5. Okay. Run this. Let's return it and just see what that vector looks like. Okay. So again, I have 5 elements in that vector. I could ask for what's the length of elk names. It's 5. Okay, I could ask what's the structure of elk names. Now here, it's no longer telling me that it's numeric. It's telling me that it's a character vector. It still has 5 elements, and then it starts telling me a little bit about what the first couple ones look like. If I ask for the class of elk names, it's going to tell me that it's a character vector. Okay, now here is where the importance of the type of vector really comes into play. What if I wanted to calculate the mean of elk names? If I run that, it gives me a warning, and it tells me that elk names is not numeric, it's not logical, it's going to return an NA, meaning a missing value there. Okay, same if I was to do the standard deviation of elk names, I would get the same thing, because these are mathematical operations that I'm trying to run on basically words. It's created NAs. Again, I get this warning message. What happens if I tried to do 3 times elk names? What would happen here? Okay, I'm getting an error again because it's telling me that I'm trying to do there's a non-numeric argument. That's because elk names is non-numeric, and I'm trying to multiply this non-numeric quantity by 3. Doesn't work. Okay? So that's okay. These character vectors are still useful for labeling things, but just be aware that if you start to get these errors, it's because your vector might be non-numeric. This can also happen. I'll show you one more thing that can happen occasionally. So let's do something like this. So let's say we have elk ages here. How old are each of these females? Create a new vector for that, and we'll say the first female is 1 year old, next one is, I think, 1 year old maybe, 2 year old. Now let's say this fourth elk, I just had the word 3 written in there, and then the last elk was 2 years old. Okay. Now, I'm going to create this. Now we see here that I've mixed numeric entries with this character vector, or this character element here. And so I ran this. I didn't get an error immediately. Let's take a look at what this elk ages vector looks like. So I can see every element in here is surrounded by these quotation marks, meaning that R has automatically changed all of the elements in this vector to character strings. Okay, and so then if I was to do elk ages times 3, again, I'm getting these errors in there. And this would occur even if I had 3 here written in quotations, meaning that R is reading this number 3 as a character vector. So I'm going to run that, take a look at it. Again, it's converted all of them to characters. And even when I run this, it doesn't work. Guarantee this will happen to you at some point. When you read in your own data, you might have made a mistake somewhere in entering, or there was just one keystroke that's off somewhere in your data, and then it might read in all your data as a character vector. We'll figure out how to deal with that later in the course, but for now, just be aware that that can happen. It probably will happen. It's happened to me I don't know how many times, and it'll drive you absolutely insane. So, okay, let's go ahead and actually so for when you guys are going through this later, let's go here, elk ages, and let's just comment all of this really quickly. I'm just going to fast forward. You don't need to watch me actually do all this. Okay, this has all been commented now. And so we're going to move. We've been through a lot already. We talked about, so far, just basic operations in R, creating sequences, repeated values. Then we talked about creating objects, so assigning single values to a variable name like X, Y, Z, and how to list those objects and remove them from your working directory if you need to. Then we moved into actually storing a bunch of values into an object as a vector. So again, these are just sort of one-dimensional like strings, one-dimensional sequences of values. They could be numeric. They can also be character vectors. There's other types as well. They can be logical. There's all sorts of different types they can be in R. But the last thing we're going to talk about today is creating data frames. And these are akin to the tables that you're used to seeing in Excel. So these are going to be two-dimensional. They're going to have a length and a width. So you're going to have multiple columns and multiple rows. Let's go ahead and create a header for this section. And basically, a data frame is just a bunch of vectors that are joined together. I'll start just by clearing the working memory again in this new section. And let's think of a new example. So maybe I have a bunch of different bird nests that I was monitoring, and maybe there's a certain number of eggs in each nest. So let's call this first vector bird eggs. Actually, let's call it clutch size. Let's be a little more technical about our terminology. And let's say each nest has a certain number of eggs in it. So I'm just going to make up a bunch of numbers here. Okay, we'll read that in. That's our clutch size. Maybe from each nest a certain number of individuals hatched. And so let's call this, let's just call this hatched. See, okay, so this is the number of eggs that hatch from each nest. It has to be less than or equal to the number of eggs in the nest. So we'll go 1, 3, 4, 2, 1, 1. Just like that. Should be the same length. It is. They're both 6. And let's say maybe we have a nest ID for each nest. Nest ID. I'm just going to make sure these are numbers here. 1, 2, 3, 4, 5, and 6. Okay, and I want to combine all of these values into a data frame or a table. So I can do this one of two ways. I can either create a table that has 3 rows and 6 columns, or I could create a table that has 3 columns and 6 rows. So basically stack these side by side next to each other. So we'll do it both ways. Let's first create this. Let's call this bird table, and let's first stack them by columns next to each other. So bird table columns. I do this using the cbind function. Cbind. And now within the cbind function, I put the different vectors that I would like to stack next to each other. So let's start with nest ID, and then next to that I'll have my clutch size, and next to that I've hatched. Run that, and let's take a look at it. Bird table columns. There's always a trade-off between how obvious and intelligible your object names are, and then how much of a pain they are to type out. So this is actually getting a little bit long. I might have renamed this just bird table calls or something if I was a little smarter. But anyways, let's run this. And when I look at this table, so what it has done is it's stacked these 3 different vectors side by side. Nest ID in the first column, clutch size in the second column, and hatched in the third column. I could also stack them by rows, so let's call this bird table rows. And I do this using the rbind function. And so again, I would put my nest ID, clutch size, and hatched. And then I'm going to ask for the bird table rows. Let's just run this all together. Okay, so first it bound them by rows, and then I asked for it to spit it back out. And sure enough, my first row has nest ID, 1 through 6. Then it has the clutch size for each of those nests, and how many individuals hatched out of each of those. Now, maybe we want to start pulling out individual observations from our tables that we just created. Now, if you'll remember, for vectors, all we had to do was just reference what number in that vector, what element number did we want. So let's say we want the 4th element from the clutch size vector. I would just ask for clutch size. I use square brackets and 4. Pulls out the 4th one, 1, 2, 3, 4. It returns a value of 5. Okay, now that's because I only need to put in 4 here because vectors are just one-dimensional. They just have a length. But tables have a length and a width. They have columns and rows. And so if I want to pull out individual elements from my tables, I need to reference both the column and the row. So to do that, let's say let's take this bird table rows, okay? Bird table rows. Let's just print that again, okay? And let's say I want in the first row, I want the 5th element in the first row. So I want first row, 5th column. And that should give me a value of 5. The way I do that is I use square brackets again. First, I ask for the row that I want. I want the first row. I put a comma, and then I ask for the column that I want. I want the fifth column. When I do that, it returns a value of 5. Don't worry too much about this little label right there. Let's say, okay, let's go again. Let's say I want the third row, and I want the second element in the third row. So let's go third row, and the second element, the second column. That should give me a value of 3 when I run this, and it does. Now let's see what happens if I do something like this. I'm going to ask for the fifth row and the first column. Now you'll notice in this bird table rows table, there is no fifth row because I only have 3 rows. Let's see what happens when I do this. Okay, it's telling me, yep, one of the subscripts is out of bounds. So I do have a first column, but I don't have a fifth row, so I would need to fix that. So I'd say there aren't 5 rows. And I could actually check that using this dim function. That tells me the dimensions. So what are the dimensions of bird table rows? Run that, and it tells me that there are 3 rows and 6 columns. Always rows first and then columns. So rows first, then columns. That's just the convention in R. So again, rows first, there are 3, and then columns, and there are 6. Okay, let's start getting even a little bit fancier. Maybe I just want to pull out an entire row or an entire column. So let's say I want to pull out just the fourth column here. The fourth column in this bird table rows. I want 4, 5, 2. I would do it just like this. I go bird table rows. It's my data frame. And now I'm going to leave the row blank. And I'm just going to ask for the fourth column. So what this is telling R to do is pull out everything in the fourth column. So I'm getting 4, 5, 2. I could ask for just the first. So here I'm asking for the fourth column. Here I'm asking for the first row. Run that. 1, 2, 3, 4, 5, 6. That's kind of silly because in this case, my first row is my nest ID. So I could have equally just asked for nest ID, but it's just good to know that you can do that. I could even ask for just, let's just rerun this first. Let's just reprint this again so I can see it. Okay. Maybe I just want the 4th, 5th, and 6th columns. How would I do that? So I'm going to go 4 to 6. Now I'm getting just the 4th, 5th, and 6th columns. 4, 5, 6, 6, 2, 1, yep. So this is just the only chunk of the data that I've taken. I could also do that equally by going, I put a vector in here now. So now I'm not just asking for a single number. I don't just want the 4th column. I put a vector in my call, and I want 4, 5, and 6. So do that. And again, I get the 4th, 5th, and 6th columns. I've left the rows blank here because I want all the rows, but maybe I'm even pickier for some reason, and I'm going to copy this. So I want the 4th to the 6th columns, and maybe I just want the 2nd and 3rd rows. So I want just this. 5, 3, 2, 2, 1, 1. Okay, just the 2nd and 3rd row. How would I do that? Okay, so in my rows, I just want 2 to 3, comma. In my columns, I just want 4 to 6. Run that, and it takes an even smaller subset of that table. So now this is starting to get really confusing. You could see that this might be confusing for someone to read, so I would definitely want to comment this. Grab 2nd and 3rd rows, 4th, 5th, and 6th columns. Here I would say grab 4th to the 6th columns and all rows. Grab 4th, 5th, and 6th columns. You can see using this vector notation is actually kind of useful because let's say I wanted to just grab the 4th and the 6th column. How would I do that? You probably are already ahead of me here, but if I just wanted to grab the 4th and the 6th column, I would use vector notation again, create a vector, and I would just ask for the 4th and 6th columns. Again, I'm leaving the rows blank here, so I want all of them. Pull that out, and now it's just pulled out the 4th and the 6th column and all the rows. And so here I would say grab 4th and 6th columns only and all the rows. And the same thing as that I can do with vectors, I can do with data frames and matrices just like this. So I can ask for the mean. So let's say I want the mean of bird table rows. This will take the mean of the entire data frame altogether. This probably isn't super meaningful. Like, what does it mean to have just the overall average of all the numbers in that data frame, or 3.16? Not super useful. But maybe I just want the mean of bird table rows, and I just want the third column. What is the mean of the third column? I can do it just like that. Okay. Maybe I want the mean of the 4th and 6th row. Maybe I want the mean of the 4th and 6th columns together. Okay, I would do that using vector notation again, and I would say, okay, give me the 4th and 6th, and then calculate the mean. And again, I have to make sure that I wrap this entire thing in parentheses. This will give me the mean of 4th and 6th columns. 3.3. Okay, so at this point we have now learned how to do simple operations, create objects, create vectors, and then combine a bunch of vectors into data frames. That's going to be it for this lab, and so let's just do a few final things here. I want to save my script so that I can come back to it later, and actually in this case I want to save it so that I can upload it to Canvas. So I'm going to go up here to the save, and I will put it in whatever folder I need to. So I'll go teaching and module 1. And let's just save it as Lab01 guided and commented. Okay, great. And now you guys are going to have to do this week for your assignment. I want you to go ahead and download and then open up the Lab01 assignment. So I'm going to do that right now. Go to File, Open. So once you download it, you can just double click on it wherever it is on your computer, or you can come into RStudio and then navigate to it yourself. So go ahead and do that right now. Okay, and then once you have that open, the lab consists of a few different parts. So first, I just have a student information part where I want you to enter some of your own information so I can get to know a little bit more about you and your goals and expectations for the course. So here, these are all just comments, but in this section, so you would put in your name here, and your job or your position, all this stuff. So just fill out this first section just so I can get to know a little bit more about you. And then down here is where I want you to actually start filling out your script and running some little pieces of code down here. So this first part says create an object called A and assign it a value of 5.883. I'll just show you how to do this. It's sort of, if you've watched this far, you get a little bonus right here. So I go 5.883. Okay, and then create an object called B, assign it a value of square root of pi. And so I would do that right here. Square root of pi, and then it says print this value using the print command. So then I could just print B just like this, and I would want you to run each of these just like this, just to make sure everything's working. Okay, down here, so some of these questions might have says print the value of the object C, so you would do that down here. And then it has a little question here. Why didn't this value change when we assigned a new value to A? So for these kind of questions, I'm going to want you to write an answer as a comment. So you would write down, it didn't change because, and then you would fill in your answer here. But I want you to write that as comments, just as if you were going to run this whole script as one giant chunk of code. Hopefully, if you run this whole script as one giant chunk, you shouldn't come back with any errors at the end of it. Okay, just to get used to good programming practices. So what I mean is, do not write your answers like this. Just it didn't change because now R is going to start reading this as it's going to start returning errors if I try to run my code. Make sure all the sentences you write are just written here as comments. Now once you fill out the entire lab, I want you to go ahead and save it. So I'm going to go ahead, File, Save, and then you're going to save it with your last name, _ Lab01, just like that. Okay, save that, and then upload that to Canvas under the assignments page. So when you turn it in, that's what I want you to turn in. I want you to turn in this R file. I'm going to go through your script. I'll correct anything that's wrong or make a few comments here and there, and then I'll return it to you with a grade attached to it. Yeah, so good luck, everyone. I hope you have fun with this one. You learn a lot. Make sure to use the discussion board if you're having problems. If your problems don't get answered on the discussion board within a couple days, go ahead and email me. But try to use the discussion board and Google as much as you can for this one. And I will see you all next week.